So when it comes to sequences, there are, in general, two main types of sequences to talk about. There's the linear sequence, or what we'll call arithmetic sequence, and there's the exponential sequence, which we'll call geometric sequence. So arithmetic and geometric are the two types of sequences that we're really going to focus our attention on. Now, what you see here is the general equation for a arithmetic sequence, also known as a linear sequence, but we're going to call it arithmetic sequence. And this is basically what it says. AN represents any term in the sequence. So it could be the fifth term, it could be the 12th term, right? If I denote A12, that just means 12th term. That's all that says. It's not really any sort of mathematical thing. It just means 12th term, okay? So don't think that plugging in a 12 or anything actually like does anything. All right, but excuse me. But so what some term in the sequence equals A. Now A is going to represent first term. It could also be just written as A1, but in this case they just write it as A. A1 would, just like A12, A1 would represent that it's the first term. So that's going to be the first term of the sequence. D will be the difference between terms, because a linear sequence, now again, this is specifically for linear, which we're calling, like one more time, arithmetic sequence, is a pattern of numbers in which you are adding or subtracting, I suppose, by the same number every time. So notice how this one's going plus 2, plus 2, plus 2, plus 2, right? That's an arithmetic sequence. D in that case would be 2, because the difference between each number is 2. So D is the difference between the terms. And N represents, again, whichever position term you're looking for. So if you're looking for the 12th term, then N, of course, would be 12 here. So, and then the other sequence to talk about is the geometric sequence, also known as exponential, but we're going to call it geometric sequence, okay? So geometric sequence, it has this formula. AN still, again, represents some kind of term in the process. It could be the 10th term, 12th term, whatever. A, just like the last one, is representing the first term in the sequence. R is kind of like D in the last one. Remember, D was the difference between the terms? Well, R in this case is sort of the same thing. It's the difference between the terms. However, a geometric sequence is not one in which you're adding by a common amount. It's one in which you are multiplying by a common amount. So, for example, you see here's a geometric sequence. It's not that we're adding 2 every time. It's that you're multiplying by 2 every time. So multiplying, the fact that we're multiplying by 2 every time, then 2 would be the R value here. Of course, N again represents the position of the term in the sequence. So if you look for the 12th term, N would be the number 12. Okay, so let's talk about those and let's use those a little bit. So write a possible explicit rule for the nth term of the sequence. So let's look at what type of sequence we have first. We're going 5 to 10, 10 to 20, 20 to 40, 40 to 80. Now, just by inspection, I can kind of see that this is being multiplied by 2 each time, times 2, times 2, times 2, times 2. So since it's a multiplication pattern, this is a geometric sequence. That's supposed to be a C there. Geometric sequence, which tells us, remember, our formula for that, or rule for that, was AN is A times R to the N minus 1 power. So we're going to make a rule similar to this for this specific sequence. So our nth term, which again is kind of like whatever pattern, whichever number in the sequence we want, equals A. Now, A is our first term. Now, the first term in this sequence is 5. So we're going to put 5 in there. Okay, now remember, R is how much we're going up by, or down by, sort of. We're multiplying by 2 each time here. So R, which also stands for common ratio, is 2, because that's the value we multiply to get each term. And then n minus 1 will be for, part of that rule. We're not going to plug anything in for n until we're asked for a specific position. So this is the formula I would use. Now, how I'd use it would look like this. Let's say I want to know what the 12th term would be. So remember, this is just saying the 12th term equals, it would be 5 times 2, and then I plug in the 12 for n, so 12 minus 1, which is the same as 2 to the 11th power. And you would calculate that out, and that value would be the 12th term. All right, let's look at this one. So this one, let's look at the pattern. 1.5 to 4, 4 to 6.5, 6.5 to 9, 9 to 11.5. And just by inspection, you do have to kind of do a little bit in your head here. It seems that you're adding 2.5 every single time. Plus 2.5, plus 2.5, plus 2.5, and plus 2.5. So because you're adding by a common amount, this is an arithmetic sequence or a linear sequence, which, remember, that rule or formula was this: an equals a plus d times n minus 1. So we're going to write a rule similar to this for this function. So we're going to have an for the nth term, whatever. Now a represents the first term. Our first term is 1.5, so I'm going to plug 1.5 in. D is the difference between terms. So since we're adding 2.5 every single time, then we're adding, D is going to be 2.5. And then we leave n minus 1. We leave n alone because that's part of the formula. So that's the formula that answers this question. Now, if I wanted to use it to find any term, let's say I want to find the 20th term, I would have a20, which again just means the 20th term is, and I'd put 1.5 plus 2.5, and then I would plug in the 20 for the n because I'm looking for the 20th term. And so 20 minus 1, of course, is 19. So I would just make that 19. I'd multiply it to 2.5 and finish that problem. And whatever that equals would be my 20th term. All right. So I want to skip ahead a little bit here. Discard that, because these are all basically the same thing. I didn't mean to do that. Can I? Okay. It's not going to matter. I kind of want to scroll down a little bit and find more problems to do. That are similar to ones like we were doing there. So this problem, I determine whether the sequence could be arithmetic. If so, find the common first difference and the next term. So an arithmetic sequence is a linear sequence, which means we're adding or subtracting by the same amount every time. So if we look at the sequence, we have -10 to -4. So that would be adding 6. -4 to +2 would be adding 6. 2 to 8 would be adding 6. And 8 to 14 would be adding 6. So this is, yes, this is an I don't know how to spell. An arithmetic sequence. Now, just to get some more practice on writing the rule for it, let's write the rule for it. I know it doesn't ask it for it in this problem, but we're going to do it anyway. an, so the nth term would be a, which is our first term, which is -10, plus d. D is the difference, so we're adding 6 every time, n minus 1. So that would be the formula I would use if I want to find any term in that sequence. So if I want to find the 100th term in the sequence, then the 100th term would equal -10 plus 6 times 100 minus 1. And I would just type that in my calculator, and whatever that came out to be, that would be the 100th term in that sequence. So now let's look at this one. Let's determine if this is arithmetic. So from -2 to -5 is subtracting 3. From -5 to -11 is subtracting 6. From -11 to -20 is subtracting 9, and then that's subtracting 12. So you can see that the differences are not the same here. So this is not an arithmetic sequence. This one, kind of difficult because it's decimals, but 1.9 to 1.2 is subtracting 0.7. 1.2 to 0.5 is subtracting 0.7. That's subtracting 0.7, and that is also subtracting 0.7. I wrote 0.9, I meant to write 0.7. So this is arithmetic because you're subtracting 0.7. So the rule for this one, we would have an equals, and remember, when I say rule, I'm using that formula that we talked about earlier, a plus d n minus 1. So that's what I was using on the last problem. I'm using that same thing again here. So an equals a is our first term, which is 1.9. And now, because I'm subtracting, instead of a plus d, it'll be a minus d. So it's going to be minus 0.7 because that's how much we're going down by every time. And then the n minus 1. So that's your rule again. All right, so I just wanted to show you those real quick. Let's look at some other types of problems while we're here. Yes, we already know that. So let's answer some of these, right? So this one says, find the 12th term of the arithmetic sequence. So again, it tells us right away it's the arithmetic sequence. So we know that the formula that I'm going to write for it is going to be based off of this formula, because this is the arithmetic sequence formula. So for this problem, my nth term will equal, now a is my first term, a is going to be 20 here, plus d. D is the difference, so I'm subtracting 6 from each successive term. So d is going to be minus 6. So instead of plus d, I'll have minus instead. So it'll be 20 minus 6 and then n minus 1. So that's the formula I can use for this. Now, if I'm looking for the 12th term, then the 12th term is going to be, I'm going to plug that in for n. 20 minus 6 times 12 minus 1. And I'm going to type that in the calculator, and I'm going to see what I get. So if I open up my calculator, right, we can just type this in. So didn't mean to full screen it. It would be 20 minus 6 and then 12 minus 1, just like that. And I get negative 46. So the 12th term in the sequence is negative 46. And you can see that right there. All right, so let's try one more for these. So find the 11th term. So let's make the equation. So the equation, again, is going to be based off of the arithmetic formula, which is this here. So I'm going to plug it in. So an is equal to a, which is my first term. So it's going to be negative 3. And now I'm subtracting 2 each time here, because negative 3 to negative 5 is minus 2. Negative 5 to negative 7 is minus 2, and so on. So that's going to be minus 2 for my d, and then n minus 1. So if I'm looking for the 11th term, then my 11th term is going to be equal to negative 3 minus 2 times 11 minus 1. So again, I would just type this in my calculator, and I believe that's going to be negative 23. So our 11th term is negative 23. Now this process works as well for the geometric sequence. So let me see if I can skip ahead and find a couple of those. Yeah. So determine whether the sequence could be geometric or arithmetic. So I guess we'll do that first. Now this one looks like an arithmetic sequence because you can see 193 is subtracting 7, 93 to 86 is subtracting 7, and 86 to 79 is subtracting 7. So since we're subtracting the same amount, this one's arithmetic. So I'm just going to skip ahead. So this one, 180 to 90, 90 to 60, 60 to 15. I don't see, well, if I was thinking arithmetic, 180 to 90 is subtracting 90, and then 90 to 60 is subtracting 30. So it's not arithmetic because these are not the same. So it could be geometric, but geometric, this would be 180 to 90 would be multiplying by 1/2. And 90 to 60, that's not 1/2, because half of 90 would be 45. So it's not multiplying by 1/2 either. It's multiplying, I think, by 2/3. But that's not the same thing. So this is neither geometric or arithmetic. Yeah, it is neither, whichever one you want to say. Now this one, 5 to 1, 1 to 0.2, 0.2 to 0.04. This one's a little bit tricky. It's definitely not arithmetic because this would be subtracting 4, and then 1 minus 4 would not be 0.2. It's not arithmetic. But from 5 to 1 is multiplying by 1/5. Or you can think of it as dividing by 5. 1 to 0.2 is also multiplying by 1/5, or dividing by 5. And 0.2 to 0.04 is, again, dividing by 5, or multiplying by 1/5. I'm doing multiplying by 1/5 because that's technically the R value. You're not going to say dividing by 5 and then saying 5 is the R value, because the R value is always a product of multiplication. So dividing by 5 is the same thing as multiplying by 1/5, so that's why I'm writing it that way. So the common ratio here is 1/5. Every successive term is 1/5 of the previous term. Or 0.2. 0.2 is the decimal version of 1/5. All right, but let's write our formulas. Let's go to a problem where we actually have to write the formula. Yeah, so find the 7th term of the geometric sequence. So a geometric sequence formula is this. Remember, an, and then a, r, n minus 1 power. So I'm going to use this as a basis for my formula. So I'm going to have an equals, it looks like a D, but it's really an A with the pen not working. A, remember, represents the first term. So our first term here is 3. So we're going to have 3. And then R represents what we're multiplying by. So 3 to 12 is multiplied by 4. 12 to 48 is multiplying by 4. And 48 to 192 is multiplying by 4. So my R value is 4 because I'm multiplying by 4 every time. And then n minus 1. So if I'm looking for the 7th term, then I'm going to plug in the 7 for n. So my 7th term is 3 times 4 to the 7 minus 1 power, which is the same thing as 3 times 4 to the 6th power. Now be careful, if you type this in the calculator, you have to do the exponent first, right? Or I would type it in exactly like this with the parentheses. The calculator should do it properly. But don't go 3 times 4 and then to the 6th power, because that's going to be wrong. Because you'd have to do 4 to the 6th power first and then multiply it by 3. So what do we get? I'll let this tell me. This gets us 12,288. The 7th term is 12,288. Okay. I'm going to skip that one. I think you guys get the general idea. But if there's anything else I feel like we need to talk about, I will go over it. I'm going to end the video here because I feel like it's getting a little long. And I will see you guys in another one. Okay? So, see you next time. Bye.